Hello, hope you guys are doing well. So today let's get started with our LeetCode problem of the day. Its number is 2196. Create binary tree from descriptions. And it's a medium problem. You are given a 2D integer array descriptions where descriptions are equal to parent I, child I, isLeft I. Like we will be given with this descriptions array and it is a two-dimensional array. Now at zeroth index, like this is at first row, it represent and first column it represents what? It is the parent and 15 is the child and 1 represents what? 1 represents like if left I equal 1 then child is the left child of the parent because it is 1, so 15 is the left child of your parent. Now 20 17 0. Since it is 0, so it is 17 is the right child of your parent 20. Similarly goes for 50. 20 is the left child of 50 and 50 it is the right child of 50. Similarly 19 is the left child of 1. So let's create a tree out of this. This is what mentioned in the problem statement, like indicates parent I is the parent of the child I in a binary tree of unique values. Furthermore, if is left I equal 1, then child is the left child of parent I and vice versa. Now we are supposed to construct binary tree described by the description and return its root. The test case will be generated such that the description tree is valid. Now this is my description array. Initially I'll do what? 20. So 20 will first I'll create a node 20 and then since it is 1, so I'll create a 50 node to its left. Then 20 node is already created, so no need of creating it. 17 create a node and it will be the right child of your 20th node. Similarly 50 create a node 50 and 20, since 20 is already there, so it will become left child of your 50. And again 80 since 0 represents what, right? 80 create a node 80 and attach to its right side. Similarly 19 because of 1 will attach to its left node. 19. So this is how I will construct your binary tree. Now the thing is what approach am I going to follow? Since we are given with unique values, each of the node will have their unique values. This is what like this is the crux part, and where it is mentioned like in a binary tree of unique values, like each node will be having their unique values. Now I need to create a map represent what? Each unique value will represent their node structure. Here it will be an integer because let's say if I create 20, so 20 will have some node structure, something like this: tree at the rate tree at the rate 1 2 3 4. What is a node structure? Node structure is something, it's an instance of TreeNode and which will be holding some value. Like this is my TreeNode, this is my class TreeNode, and its object will be created. It will be having two properties, two pointer left and right, and it will have two values. It will have value also. So TreeNode will be a class that will having three property: left, right, and what? Here it will be your value. So this is how I'll create. So each node will have their corresponding TreeNode. So 20 15 17 19 80 50. Like if it is already present, then we are going to use the same TreeNode. Otherwise create a TreeNode 2 3 4 5 in your map. Now if it is clear, let's do one thing. 20. Initially my map will be what? Empty, right? Empty. Now I'll create a tree node corresponding to node 20. So 20 node will be created and tree node T20, right? Then I'll create a tree. I'll see if 15 is already there. No, 15 is already not there, so I'll create 15 and tree node 15. So since it is 1, so I'll do what? T20 dot left. 1 represents left. Left will be equal to what? T15, right? Once it is clear, then I'll create what? I'll do 20. Is 20 already there? Yes, get me T20. T20. If 17 is already there, no. So I'll do what? 17, and 17 value will be what? T17. Now, since it is 0, so I'll do what? T20 dot right equal to T17. Now, this is much, my tree has already been created. Now come 50. 50 is already there, no. So I'll create 50, T50. What about 20? Yeah, 20 is already there, but I want it 20 to be its left child. So T50 dot left will be what? T50 dot left will be what? T20. Similarly, T80 is not there, so I'll add 80 into T80. So T50 dot right equal to T80. I know it's not that much clear. Once I write the algorithm, you'll get to know it much better. 80. Now 80 is already there, so 18 dot left will become what? 19. So I'll create 19, T19, and T80 dot what? Left equal to T19. Just follow along with me. Now the thing is, my whole tree is created. Now there is one more thing. How to return what? How to return what? How to return what? The root node. We need to find a strategy to return the root node. But the thing is, like in my hash map, I will be having all my nodes. Now I'll create a set of what? Children. I'll just add children in here, and finally I'll be having all the children. So what are my children? 15 will be my children, so I'll add T15 in my children's, T17 in my children, T20 in my children, T18 in my children, T19 my children. Now in my hash map, I'll have all of the. Is 20 in my children? Yes. So this cannot be my root node. Is 15 in my children node? Yes, it is in my children node. So 15, yeah, it's in my children node, so it cannot be the parent. What about 17? Same, since it is in children set. Yes. What about 20? Yeah, 20 is already ignored. What about 50? Yeah. It is not in children node, so this will be my root. I'll immediately return my T50. So let's write the algorithm for this. First I'll create a hash map. Let's write it in with green pen. Hash map of what? Integer will be representing, integer will be my key, and tree node will be my value. Like for solving this question, you must have a some prerequisite. This is understanding of the tree node. So this is my hash map, new hash map. So each, since we have unique integers, so each integer will be representing its tree node. Once it is done, I'll create one more hash map of what? And tree node. These are all my children, not children's. Children is itself plural. So new hash map. No, it's hash set, because I just need key only. Set of my children. Once it is done, so I'll do what? I'll just iterate over my descriptions. Int d descriptions. Now the thing is, tree node. I'll first create a function. To get me the node corresponding to that integer value. So let's create private. So it will return what? Tree node, because I want node corresponding to that integer. So it will take a number, and along with that what? Along with that it will take my tree map, hash map of representations, integer comma what? Tree node, and it will be my what? Hash map. Now the thing is, if my map does not contain, if my hm does not contain the key x, do what? Enter this hm dot put x comma new tree node. This is how I am going to create my tree node and X. Once it is done, and whenever this new node is created, this will be this constructor will be called to create the object of this tree node, this one. So once my tree node is created, I'll do what? Return hm dot get X. Now till here it is clear. Now what I'll do, I'll just I'll just find out the parent. Parent will be what? Just use this function to get the tree node corresponding to what? K D0 because at 0th index, 0th column, my parent will be there. Similarly, I'll get the tree node of what? Child. Child will be what? Get node and D1. Now add your child to children. Children dot add and child. Once it is added, I'll do what? Children is added. Now if D1 D2 equal 1, I'll do what? Parent dot left. Children will be a child will be its left, will be on its left position, else parent dot right will be what? Parent dot right will be child. Once it is done, close your for loop. Now the thing is, I want to because my whole, after description, my whole tree will be constructed. Now I got to find a way to return the root node. Now iterate for tree node, iterate over your whole map. Tree node T O and what will be there? Map map dot key set. Now if children does not contain T, then return what? Return T. Once you come out of the loop, return null, because that wouldn't be the case. And finally close your for loop. So let's get started with its implementation. So first create a function. Function will be what? Function to get the tree node. Tree node from where? Tree node from the integer value. Now tree node, and this will be my return types. Create it private. Function name will be getNode. It will take two things, int x and HashMap of integer, comma, tree node and hm. Now if hm does not contain what? Contain key. Which key? X. Then hm dot put, or hm dot put if absent also we can do. hm dot put x comma what? New tree node of x, or sorry, we can use this function as well. You can try hm dot put if absent x comma new tree node of x. Finally I'll do what? Return hm dot get x. Now I'll create a hash map representing the integer to its corresponding tree node, equal to new hash map. So one will be hash set representing the children. So TreeNode children equal to new hash set. Now, oh sorry. Now I'll do what? I'll iterate over my descriptions array. Int d descriptions. Now what will be my parent? Tree node. Parent will be what? Get node T0 D0. Similarly, tree node child will be what? Equal to getNode d1. Now add children to your children set, child you to your children set. Children dot add what? Child. Now based on the d2, if d2 equal to 1, equal 1, then parent dot left will be what? Child. Else parent dot right will be child. Once it is done, iterate over your map to node and hm dot key set, not key set values, because values will be my node. Now if children set node contains what? Node, return node, and finally I'll return null. If somehow there is no node, that wouldn't be the case in any of the case, or throw new illegal argument exception, whatever you want. It's expecting me to give hm because like here it's expecting two arguments, but we have passed only one. So what else? Let's see. Now what is the time complexity? We are iterating over our descriptions array, so it's big of n. Anything else? And along with that, like we are iterating over every node, so it's like big of n plus big of n. So time complexity will be what? Big of n. What about space complexity? Space complexity, we are creating children, like every children, so it will be big of n almost, and each node big of n, so time space complexity will be big of n. So let's try to submit this. Yeah, it got submitted. Thank you very much, and if you guys have any doubt, feel free to ask, comment, and that's all from my side. Thank you guys. Bye bye, take care.